Hello. In this video, I'm going to be explaining a problem from the 2017 F=ma contest. This is problem number 13. In this problem, we have a massless rope that passes over a frictionless pulley, and we have particles of mass big M and big M plus little m. So I'm going to start drawing out the diagram. And basically, the question asks for what will happen to the tension of this string in the limit as the mass little m goes to infinity. So in this case, because the string is massless and the pulley is frictionless, we know that both sides of the string have to have the same tension T. We know that of course the two blocks will get pulled down by gravity. And so in this first method of solving the problem, we're just going to work through the equations without any special ingenuity and just see where the mathematics leads us. So I'm just going to say method 1, just do the math. So for the block of mass m, what is the equation we get? We get that T minus mg is equal to m times a, where a is the acceleration of both blocks. This will be important because we'll actually be able to use the fact that the acceleration is the same for both blocks to then have an equation in just one variable, which is t. So now for the mass m plus little m, we will have that m plus m times g minus t is equal to big M plus little m times a. One thing I glossed over, but which is fairly clear, is that the blocks will indeed accelerate in this direction. That is, the block of mass m will go up and the block of mass m plus little m will go down because this is the greater mass. So now from these two equations, here's what we can do. We can multiply this first equation by the quantity m plus little m, and then multiply this by the quantity big M, and then what that will do is that it will allow us to eliminate a. So let me do that right here. So I will get big M plus little m times t minus m times big M plus little m times g equals m times m plus little m times a. And then for the second equation, we're going to get negative mt plus m times m plus little m g equals m times m plus little m a. Now we're going to subtract the second equation from the first equation. And so what are we going to get? Here, this negative m becomes a plus m, and so we're going to get 2m plus little m times t. Here we're going to get minus 2m times m plus m times g. And here, of course, we're going to get 0. And so now we can solve for t, and we get 2m times big M plus little m times g divided by 2m plus little m. So now this is the expression that we're going to use. And so now we need to see what happens as little m goes to infinity. So one remark I make is that we can actually derive a general formula for any masses m1 and m2. And using this exact same method, and what it turns out is that the tension is actually going to equal the harmonic mean of the two masses, which is basically the reciprocal of the average of the reciprocals, and then of course times g. And so in this case, again, what happens as one of these masses comes to completely dominate the other? So what happens to the harmonic mean as one of the terms goes off to infinity and the other stays the same? Well, let's say m2 goes to infinity, then m1 plus m2 is basically the same as m2, right? Basically, more formally, m2 over m1 plus m2 approaches 1. And so what happens is that t will approach 2m1g. Now, if you look back at our old expression, the one that is specific to our problem, you're going to see the same thing here. So let me write out the expression. Oh, did not want to do that. Let me go back here. So we had t equals 2m plus little m times g over m plus 2m. Well, as little m goes to infinity, m plus little m over 2 big M plus little m is going to approach 1, which means that t is actually going to approach 2mg. And you see that t is increasing, so t is increasing and approaching this value. Because 2m plus m, because clearly this numerator is less than the denominator, m plus m over 2m plus little m is approaching 1. It's less than 1, but it's approaching 1, so it's increasing. Right? And so now let's go back to our options and see what the different options are. And you can see that the tension T is increasing and approaching a finite constant, and so our answer is D. Now, I mentioned that there is another way of doing this problem without going through all of this mathematics. It's not that much mathematics, but if you have a good intuition, and honestly, like if you're not comfortable with handling the intuition of physics, and if you don't feel safe doing this, then I would highly recommend just going with the first method, so that you can work with the mathematics and just be safe knowing that you're doing the right thing. But here is the second method. If you wish to work through this problem very quickly. And if you have a good intuition for these sorts of things, this method may help you solve the problem a lot faster. So let me draw the setup again. This is our frictionless pulley, massless string, right? So basically, notice that really this mass, big M, is basically sort of the think about what if this mass wasn't there, right? Let's say it just wasn't there at all. Then there would be nothing holding this mass back from free falling, right? It would just go into free fall and accelerate at acceleration g, right? It would just be in free fall. Now, basically, as m goes to infinity, what basically happens is that relative to this very big mass, this mass matters less and less and less, and so you can say that the mass m plus m approaches free fall, or approaches the free fall situation as little m goes to infinity. Now, in this case, what does the tension have to be? Well, if m plus m is I'm going to erase this cross out because, of course, this mass is still there. So let me just redraw it. If this side is accelerating down with acceleration g, then this side better be accelerating up with acceleration g. And so what tension is now required to accelerate the mass m upward with acceleration g? Well, we know that a force mg is acting here, which means that t minus mg must equal mg, because the block is actually accelerating upward with acceleration of g. And so t will actually equal 2mg. And of course, this is as m goes to infinity. And in the problem, if you notice the problem statement, it actually mentions that at m equals 0, t equals mg. This is something you could also calculate for yourself pretty quickly, just from the fact that the two blocks would be in static equilibrium. But in this case, they actually give it to you, and so you can see that t would increase and approach a finite value 2 mg. And so once again, you get the answer D. One thing you have to be very careful about is that the tension is that at this step where we said that m plus m approaches free fall, you may be tempted to think that, oh, maybe the tension will just approach 0 because, oh, since it's free fall, there must be nothing supporting this mass. But that is not the case, right? You should not fall for that temptation, because it's also possible, and indeed true, that maybe the tension approaches some non-zero value, but just something that becomes negligible compared to the gravitational force, which is m plus m times g. And as we can see in this problem, that is indeed what happens, where the tension approaches 2 times big M times g, but that is nothing in comparison. And so that's not 0, but it's nothing in comparison to big M plus little m times g. And so that is, those are the two methods for solving this problem. Thank you for watching.